we are talking about recursion. So recursion is one of the methodology that is a kind of uh, 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 a way to achieve a repeated thing. There are two ways to achieve a repeated thing. If I have a repetition, if I want to calculate something that is repeated, like factorial, if I know the factorial of something, then next factorial is calculated on the previous calculation. So if I want to achieve the repeated thing, then I can go for control statement like while for the looping. This is the one way that I can loop and I can get the get our work done. Another way is calling your function again. You can loop through or you can call your function. That is also a kind of repetition, iterating. Iterating through a loop or iterate through calling your function again. What is the difference between these two? Recursion is when we call our function again, that function calls itself again, that function calls itself again. It comes in a chain. And it is an iterative process way to get something, get any work done. So what is the philosophy behind recursive function? When we see a function, when we go for any technology, first we see that what is the kind of framework that is already with us. If I go for 3D drawing, then I have to choose which language I should set upon, either it is C++ or Python or whatsoever, because that much is already available to you. So when we go for recursion, because we know that if I enter a function, I have a ready-made local context, function argument, and function argument is a kind of data that is passed from outside, whereas a function can instantiate its own set of data, which will go away if function comes out. So function creates a context. So there are two things. If I enter a function, there are two things in a sense. One is intrinsic and one is extrinsic. This is similar to flywheel design pattern, where we have intrinsic data and whatever data we pass from the outside. So for a good design, intrinsic should be more and extrinsic should be less. I should not pass 100 parameters to a function. I should pass as less as possible. And intrinsic should be more. It's a kind of internal energy and external energy in physics, where how much internal energy any entity carries and how much external energy it needs to get something work done. So best is internal energy should be more, external energy should be as less as possible. Same design in recursion. When we enter into a function, it has internal context. That context we can use to get something done. Extrinsic we pass through to the function as an argument, and whatever this function returns, that comes back to the intrinsic of the previous function. So this way we proceed. Since similar algorithm works in same function because code is same. So as per the new context comes into the picture, we get some work done in a iterative way. So this is different than loop in the sense that in loop also we can have local variable. But framework is not inbuilt. We have to create our own local variable and we delete every time we repeat the loop. It's cumbersome. This framework is already available in the function. You get something on the stack and it gets washed away when you return from it. So we can use this context feature of a function and we can repeat the same code because it is the way we are looking for a work. where repetition is required of the same work. Whatever we have done, similar kind of thing we have to continue, and we can get our own. So that recursion is subroutine recursion. So we'll proceed on desktop. This is Linux Mint. Okay, so we'll proceed point by point. Subroutine recursion is not a new topic, so we'll put more insight into it. Our subroutine can call other subroutine like it can call itself. When it calls self, it becomes a recursion. But from program perspective, anyway, there is no difference. Subroutine call creates a separate execution context and it solves iterative problems. So recursion is when a function calls itself. That is a recursion. Normal function call. A function calls another function, then calls another function. That becomes a normal function call. Whereas in recursion, a function calls itself. That becomes a recursive function call. From OS perspective, there is no difference. For each function, it creates a entry into the stack area and one frame is generated. So many frames because so many function gets called. And if normal function call is there or a function calling itself, no difference. So recursive function call is to solve a problem. That's where it is important. So how we'll see what is recursive function, how it solves a problem. So a subroutine, a function, a definition, it receives external parameter and instantiate local variable. With local variable and code, it creates a local variable context. That is the key point. Every function creates an entry into a stack area and one frame is generated. And it has separate local variables. So in each frame, separate local variable exists. So it creates a context. Now, if you see like control statement where looping is there, no local context. So if I say for I in range 10, print I, nothing is generated. So a programmer has to do itself. But if I say def func I and print I and call func again and again, every time function gets called, a separate context is created. How we will use this? Default creates a default local context. So with every local context creation, how we can use it now for solving an issue, solving a problem. That problem cannot be solved through control statement. It has a function. Okay. So as discussed, if there is a function, then there is a context creation. Let's go more into the context. If there is a context, that is a black box, then there are two things. One is extrinsic variable and one is intrinsic variable. So intrinsic variable is kind of its internal energy kind of thing of any substance, whereas extrinsic variable is whatever we pass externally. So it is similar to kind of flyweight pattern, design pattern. In behavioral design pattern, it is similar to flyweight design, where we have extrinsic and intrinsic. So as per design pattern, extrinsic should be as minimum as possible. Better if we can push into the intrinsic variable. Extrinsic variable triggers it and then intrinsic So extrinsic variable triggers the intrinsic variable and computation happens. So, like if a subroutine B calls A, then and B itself has parameter pair 1, pair 2. So for B, extrinsic variable are these two, whereas variable 1, variable 2 that is declared inside the B, that becomes intrinsic. For A, this is intrinsic. So for B function, extrinsic, intrinsic. Now it calls subroutine A, B calls subroutine A, and it has now A has two extrinsic, whereas it has one intrinsic variable. Once it executes, it returns back to the B. Now it mixes everything. Extrinsic variable, intrinsic variable, and whatever is returned all becomes intrinsic at the end, and then it returns back. So we can see two functions are there. So two context creation. This context creation is missing in the loop. We have to do ourselves. This is provided by the compiler. So this context creation, every invocation of a function, new context creation. So that is used as far as recursion is concerned. Okay. So we are now more explicit. It is context 0 if this function gets called. Next function is context 1, and then next function is context 2. So three contexts are there, 2, 1 and 0. So three context creation happens. So we'll see that how these contexts are important. Okay. So now we'll see how many types a subroutine recursion can have. One subroutine is direct, that we saw. One function calls itself. And there is another subroutine. Okay. Okay. So there are two subroutines. One subroutine we can see here. This is a function calling one function. Another subroutine that we can see. A function calling another function. A function calling another function, and then this function calling func2, another function, and this function calling it back. So this is kind of a mutual recursion, indirect recursion. Function calling another function, this function calling back that function. This way there can be many functions calling each other. So this is indirect way of recursion, whereas this is direct way of recursion for function calling itself. Again, from the OS point of view, there is no difference. Okay. Now let's see the context creation. When a function gets called, context 0 is created. Then it calls itself, context 1 is created. It calls itself. Like this, if there is an n call, the n context are created, n plus 1. If there is n plus 1 call. So this is the way context creation happens. So we are heavily focusing on the context creation because recursion has no difference when a function calls another function. It is same as a function, but when we get a context, then it makes difference between recursion and a control state. We'll take an example. Like I have a number, I have a string 1, 2, 3, 4. I want to convert it to tuple. Tuple is created. Okay. So when I call a function, one context is created, context 0. Now I have another string. We can see now. 1, then, so this is a string. where this is a kind of a braces, then again braces, again braces, again braces. Now this would be converted to a tuple. If I have a string, it gets converted to a tuple. If I have a string, now I want to convert it to tuple. Now function nicely converts a string without a braces to a tuple. But here string is kind of it's a hybrid one. So when I call this function, now it has few things at one layer. One, and then complete this step, then this step, then this complete this step. So there are four entries. Those are at one level. We call it context zero because this will be simplified in the first function. Now this guy calls another function, this one, because it finds the braces, it enters into another function calling itself and it creates context 1. Since it knows 1, 2, 3, 4 to convert it to tuple, it returns back the tuple that get mixed with the context 0. It is similar to this. Okay. So when a function calls another function returns something and it gets mixed up with its intrinsic component. Okay. So this context 0, one function calls itself and this is a new string it passes. This string gets converted and comes back to the context 0. Similarly, it will call this big guy. This big guy has another context and then it will call this guy in another function, that is context 2. And then again it will call this guy because this is what it knows. If it receives a string without a braces, it would convert it to tuple. So it will come to context 3. Context 3 creates a tuple, returns back to context 2. Then it returns back to context 1. Then all tuples come to context 0. So I have a function. That function knows to convert a string to a tuple. That's it. This function, whenever this function receives a braces, it calls itself because that's what it does. In different contexts, it returns the tuple and finally the tuple gets assembled to a big tuple. So this is the kind of recursion. So we'll try coding this and we'll see actually it happens. So program should be simple and we'll see how it is. Okay, so we'll develop the application. We create one directory. Now we'll create a program, kind of subroutine recursion.py. And now we'll write the subroutine str to tuple, and a is a string. Okay, so this function receives the tuple as per the. Okay, so there is a context 0 that at the beginning and then context 1 and 2 and 3. So that is the idea. So I'll say A equal to empty 1, there is one DD equal to empty, and there is one II equal to 0. For count I in enumerate A. So we are going character by character, that is the idea. So this is what we have to do. And if I equal to, so beginning brace and A count not equal to if count S2. This is typical Python code. What we are trying to do is, if it starts and from its beginning brace starts and A count not equal to, I believe it should be A count minus 1 not equal to. Okay, so this is the code where A count minus 1 not equal to. So this begin brace should not be escaped. So it should be real begin brace. So that is the concept. If count else true. So we will proceed. DD dot append count L if I equal to R and A count minus 1 not equal to L if. So if it is a beginning brace, then we append to a list called DD the count, and else if it is end brace and A count minus 1 not equal to, it is not escaped, then we will push. So what we would do is, if I encounter begin brace and then encounter end brace, so up till begin brace means from ONE up till here. So this is finalized. That is context 0. And since we have received a brace, begin and end, this will go to a recursive function. After this, from here to here, that is finalized, context 0. And then this will go to a recursive. So that is the concept of recursion. Whatever comes in context 0, that we finalize. Otherwise, call the function again. Here, from brace begin till brace end, and brace begin till brace end. This would go in recursion, whereas this part and from here to here, this will be handled here only. And whatever this recursive function returns, that will be added. Further, this would be added. Similarly, once it enters into this function, from here up till here, it would go to second brace, go to another function. In that function again, from here to here, it would go to another function. So it is creating context by context. So if it ends curly bracket, we will check if length is 0. This is belongs to us, this context. If length equal to 1, if that is the context, A dot extend is substitute okay. So R is substitute. So this ends. X for X in RE split. So this is back assertion negative, back searching negative, IIT to 0, IID to 0, if X. Okay. So this is typical Python code. What we are trying to do is we are splitting with comma, where it is not kind of prepend. It is not. It is not following any backslash, and then we are starting from, as we can see, we are starting from II where the last brace ended till the right now. So II is so where the last brace ended, and till D0 means where the brace starts. So here what we are trying to say is, if brace ends, then where it started till from here to here. If I am here, then where last brace end from here, when it starts from here to here, we push. So we are splitting comma by comma, and then from the II to D0, and if X D0, if X. Okay, so that is the idea. Now we will do quickly, we'll extend. Now we'll make a recursive call. str2 tuple and add0 plus 1 to count if dd0 equal to 0 and count equal to len a minus 1 is a dot append str2 tuple. So again, one place we are doing extend and other place we are doing append. Where we are doing what, that we'll see. Plus 1 count II equal to count plus 1 and we will do pop dd dot pop. I think that's enough. So we will see the function. So this function accepts a. Then now we are enumerating a. If I, each character by character, that is I, and if I is beginning braces, then we remember it in a list, and if it is ending braces, then we are checking that the list is size 1. I mean, if we are here, then we are pushing this, and this. If we are here, then we don't bother, because this is not our context. Here, don't bother. End 1. This we bother. So if length is not 1, then we simply pop dd.pop. If length is 1, then we are ready to push into another context. Now we'll extend RE substitute. If it is a comma or curly braces whatsoever. So if this is the case, okay, that we get it for X in, we split by comma, not kind of if it is not followed by backslash and aidt0 x. Okay, so this is the code. Now we'll make a recursive call one. So if it is if dd equal to 0, in case if it is like this, if it here it doesn't start from a brace, if a string starts from a brace and ends in a brace, in that scenario, that is typical scenario, so that we are identifying if dd0 equal to 0 and count equal to len a minus 1, then in that case we extend, we call add0 plus 1 up till count. Same thing here, but we append else add0 plus 1 count. Okay. Now I think it matches. So, okay, now we increment the II to count plus 1 and depop. Now this loop is over. Now we are here. Kind of if scenario is that, so this is kind of, we consider a case like 1 A, B, 3, and then we have 2, 3, and then it ends like this. So in this scenario, from here till end, that also we need to push. So same thing we are doing. So this we'll just copy and paste here, and it is above the for loop. So once for loop is over, so we finish it. So we do the same thing. Split I from I. Here it would be, since it is finishing it, it would be length of A. Return tuple of A. So this is the code. Okay, from AII to DD0, and here length AIA, length of A. Okay, so I think it's time to execute this code. So as we said, this is the recursive. So we can say Python 3 minus C import subrec and subrec dot str to tuple ABC. The beginning one will try, and okay, so A is not defined. So we'll import RE, that is missing. Okay, it's compiled the code. We'll print it. Print. Okay, so it is printing the tuple. We'll try more complex in the sense. Oh, it prints. So If I have a string ABC and then like this, then it is printing a tuple. It is clear that this guy is a tuple. Okay, I try another one. Okay, this is what we want. So, we'll execute with generic function. So, we load this guy. So, we are inside temp and then here, then this is a function. So, we have a string to tuple. So, we load. It's a string parameter. So, now we'll kind of type whatever we have. 1, 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 9, 10. Okay, so here it ends. So 1 braces 2, 3, 3 ends. We'll try with some more thing like quick 10. That's it. So this is a string where we expect a tuple here, and then this is kind of a recursive tuple. Then 1, 2, 3, and then we'll try. Oh. So we have a tuple at the end. What we do now is we'll modify this guy. We'll print this A here. We'll say at the beginning of function, whatever is the A. And at the end, when it is returning it, there we'll close closing function, and this is what it is returning. So we'll print. So stack by stack, we'll receive what it is receiving, and stack by stack, we'll print what it is returning. We'll try if it is reloads it. Okay. We'll try to load again. Okay. B, C. Okay, so looks like it is not reloading, otherwise it will print. So try opening it again. Generic function. Temp. Okay, so we load this function. Okay, now I'll try if it prints. Oh, better. So, okay, so it is not printing the value. Print F, formatted string. We'll try again. We will load. And okay, so we'll see now it is printing better. So it receives the string and it going to one context and printing the output. So now we'll make whatever we want. So it is like
1, 2, 3 and 4, and then 5, 6, and then 7, 8, 3, 4, 5, 7, 8, 3, 4, 5, 9 and 10, quick exit. So 1, 2, 3, 4, 5, 7, 8, 3, 4, 5 and 3 braces in quick. So I think we are done. Okay. So it enters with 1. This is the string. Now we can see this is the 1, 2, 3 and 4. This is the first it going into a different stack. Then it ends with it enters the function with this and comes out with the tuple. Then full up till here, full going in another context. Then this is going into another context because of the brace. Then this is going into the another context, the 3 beginnings. And then 3 tuples are returning. That's it. And finally, it is returning the full tuple. This is what is expected. 5, 7 and so recursive function, if we see our function, actually does nothing. If we see the function code, it does nothing. If it is beginning brace or an end brace, up to that we push in the tuple and we call the function again. That's it. There is nothing here if we want to change the string to tuple. But since every time it enters into the function, it creates a context. A is different, DD is different, II is different. It is doing the magic. And then it is creating into the tuple and return. So a function does nothing. Just number is there, it is creating a tuple. Wherever we are finding a braces, we are calling it again and again. And we are getting what we want. So, tuple. I can go as many I want. 1, 2. So this can be a good example where I think it would be 1, 2, 3, 4. Okay. So this is the end tuple. So this is actually a tuple, as we see. It returns. So I can say, instead of printing it, I can just print the type of it. So print type, whatever we receive, just print what is the type of this. Okay. So print type of whatever it returns. It returns class tuple. Okay. Thank
you. If you are looking for Kiwi or machine learning training, or you are looking for Kiwi and machine learning application development, or you are looking for porting your QTQML application to Kiwi, or you are looking for 3D OpenGL application development, you can contact us. You can also sponsor our videos. Please do contact.